Good day, class. Welcome to another edition of Class University Secondary School online chemistry class. I am Solomon, your online chemistry teacher. Now, in our last lecture, we were talking about sulfur, and today is just going to be a continuation of where we stopped in our last lecture. Now, this was the practice question I gave you guys for the last lecture. You can get as many as possible, as many uses of sulfur as possible. Now, but for the second question, this is the solution to the practice question. Now, today we'll be discussing hydrogen sulphide. Now, under hydrogen sulphide, we're going to talk about its preparation, its physical properties, chemical properties, and how you can test for hydrogen sulphide in the lab, and after that, uses of hydrogen sulphide. Now, hydrogen sulphide is found in volcanic gases. I hope you can remember this in our introduction when we were discussing the occurrence of sulfur in nature. Now, in volcanic gases, sulfur spring and coal gases and gas is formed during the decay of organic compound. That means after dead organisms or dead animals and plants decay, when they undergo decomposition by bacteria, then hydrogen sulfide can be produced because the body of organic compound containing sulfur like animals and plants, they are made of some proteins which contains sulfur. Let's take note of that. That is why hydrogen sulfide can be liberated from during the decay of organic compound. Now, preparation. Hydrogen sulfide is prepared in the laboratory and commercially by the action of dilute acid on metallic sulfide like iron sulfide, which is iron 2 sulfide. And this dilute acid on iron 2 sulfide, and you can see the hydrogen sulfide being liberated. Now, the acid you use here is the dilute hydrochloric acid. Dilute hydrochloric acid. Now, we use an apparatus which is called the Gibbs apparatus for the preparation of hydrogen sulfide. For hydrogen sulfide. Now, as you can see in this diagram, instead of we using dilute hydrochloric acid, we are making use of dilute hydrogen tetrasulfate 6 acid H2SO4. Now, please don't forget I said action of dilute acid. I didn't specify hydrogen hydrochloric acid. Please let's take note of that. Now, this 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 region contains this region contains uh the acid, while this contains the iron sulfide. Now, this region, after the whole reaction has taken place, this is the deposit of FeSO4, iron 2 tetrasulfate 6. Now, you know that when iron sulfide reacts with H2SO4, iron 2 tetrasulfate 6 will be formed as the hydrogen sulfide is being liberated. Now, this step is that is where the hydrogen sulfide produced will be collected from. Then through this step, we can connect a pipe to collect our hydrogen sulfide gas. So from here we can see that this and this contains this region and this region contains the liquid part of the reaction, while this contains the solid part of the reaction. Please take note of that. This region and this region contains the liquid part of the reaction, while this region contains the solid part for the reaction. Now to the physical property of hydrogen sulfide. Hydrogen sulfide is a colorless gas with a repulsive smell like that of a rotten egg. Now, it is very poisonous and it is about 1.18 heavier than air. and it is moderately soluble in water. And please take note that it burns with a blue flame, but it does not support combustion. Let's take note of that. Hydrogen sulfide does not support combustion. Now to the chemical properties of hydrogen sulfide. Now reaction with oxygen. Hydrogen sulfide does not support combustion, wow, but it burns in a plentiful supply of air with a bright blue flame to produce sulfur 6 oxide, that's SO3. Now this supposed to be SO3, not SO2 gas. It's supposed to be SO3 gas. That was a mistake on my part. Now if the supply of oxygen is limited, a deposit of sulfur may be formed. Now don't forget, in our discussion in our last class, when I was talking about the occurrence of sulfur, now I said sulfur is prepared from volcanic gases and from oxidation of hydrogen sulfide in limited supply of what? Oxygen. Now as you can see, sulfur can be prepared in limited supply of oxygen when it is made to react with hydrogen sulfide gas. Now, as an acid, hydrogen sulfide ionizes slightly in water to produce a weak dibasic acid, which exhibits typical acidic properties. Now, hydrogen sulfide behaves as what? A weak dibasic acid in water. Please let's take note of that. In water and not as a gas. Please let's take note of that. It only behaves as an acid in water, and also it behaves as a weak acid and a dibasic acid in water, as you can see. This is showing the ionization process of hydrogen sulfide in water. Now, when it is bubbled through an alkaline solution, a normal salt is formed together with what? Water. Now, please, if you take note of this equation, this sodium hydroxide reacting with hydrogen sulfide. Now, this is an HL solution. And don't forget that an HL solution is any solution that contains water, because a solid has been dissolved in water. When we have a solute dissolved in water, that is when we have an aqueous solution. Now, when the hydrogen sulfide is meant to react with this sodium hydroxide, the hydrogen sulfide will first ionize in that water, then react like an acid with the sodium hydroxide to form the sodium sulfide and form water molecules. This is just a typical neutralization process. Now, as a precipitating agent, in aqueous solution, hydrogen sulfide forms many salts known as sulphide, which are colored and are insoluble. Now, this property is applied in quantitative analysis. Now, when we are discussing sulphide, we will talk about the color of all these salts, of the most common ones that we have. For example, we have the lead sulphide, the silver sulphide. When we get there, we'll discuss that. Now, for example, when hydrogen sulphide is bubbled through the solution of lead nitrate, now lead nitrate is soluble in water, but when hydrogen sulfide is going to react with lead nitrate, a black deposit of lead sulfide is formed. Now, this is to indicate to you that lead sulfide is black. The color of lead sulfide is black. Now, so when you are having a reaction, or okay, in let's say in a quantitative test, you know that your cation is you know your cation, you don't know your cation, but you know your anion. And when I talk about cation, I talk about the metallic ions like the sodium, the potassium, the lead. Now, and when you pass the solution, when you pass hydrogen sulfide into a solution containing a salt, and you have a deposit of a black deposit, then you can suspect that it is lead sulfide. Please don't forget that you can suspect that it is lead sulfide. From this equation, you can suspect, right? Now to the next one. as a reducing agent. As a reducing agent, hydrogen sulfide is being oxidized by some oxidizing agent to sulfur. Now, for example, when hydrogen sulfide reacts with tetraoxomanganate 7, that's KMnO4, creates an acidified solution of potassium tetraoxomanganate 7. The color of the tetraoxomanganate 7 changes from purple to colorless, and a deposit of sulfur is formed. Right? Now that means hydrogen sulfide decolorizes acidified potassium tetraoxomanganate 7 from purple to colorless, but a deposit of sulfur is formed, and under sulfur we said that the color of sulfur is yellow. Now when you are performing a reaction like this, you have an oxidizing agent and you now pass hydrogen sulfide into the oxidizing agent, but you don't know the oxidizing agent. You don't know whether the okay, well, let's say you don't know whether the solution is an oxidizing agent or is an oxidizing agent or a reducing agent. But when you pass hydrogen sulfide into the solution and have a deposit of sulfur, then you can conclude that that compound, that solution is an oxidizing agent. Please let's take note of that. Now, under the reducing property of hydrogen sulfide, now reaction with halogens. Now what are halogens? Halogens are the group 7 family, the chlorine, fluorine, bromine and iodine. Now when hydrogen sulfide is made to react with any halogen, the halogen is reduced to the hydrogen to their hydrohalide. For example, when chlorine gas is made to react with hydrogen sulfide gas, hydrogen chloride gas is formed with a deposit of sulfur. With a deposit of sulfur. Please let's take note of that. And please take note that for the reaction to take place, moisture must be present. Moisture must be present. Now with sulfur 4 oxide. Now, we all know that sulfur 4 oxide is a reducing agent, but sulfur 4 oxide behaves as an oxidizing agent when it is made to react with hydrogen sulfide. Now the sulfur 4 oxide is reduced to sulfur, while the hydrogen sulfide is also reduced to sulfur. Please just take note of that. With oxidizing agent, oh sorry, this with oxidizing acid, hydrogen sulfide is being oxidized by concentrated tetraoxomanganate acid to sulfur, but the acid is then oxidized to sulfur 4 oxide. Oh yeah, but the acid is reduced to sulfur 4 oxide. That means hydrogen sulfide, when it is made to react with concentrated tetraoxomanganate acid, it is being oxidized to sulfur, to ordinary sulfur, while the concentrated tetraoxomanganate acid is reduced to sulfur 4 oxide. Then if you check the oxidation number of sulfur in H2SO4, you find out that the oxidation number of sulfur is +6, but in SO2 it is what? +4. Now that is to tell you that sulfur has reduced in this compound from +6 to +4. That means hydrogen tetraoxomanganate acid, concentrated tetraoxomanganate acid, has been reduced by the hydrogen sulfide. Now if you check the oxidation number of sulfur here and here, you take note that the oxidation number of sulfur in H2S is -2, while that of sulfur here is 0. That means sulfur has increased from -2 to 0. It has been oxidized. Let's take note of that. Now, hydrogen sulfide is oxidized to tetraoxomanganate acid to some extent by concentrated triazonitrate 5 acid. Let's take note of that. Now, how do we test for hydrogen sulfide in the lab? Now, we can test for hydrogen sulfide in the lab using its smell. From its smell, we can detect it in the lab from its smell because it gives a repulsive smell like that of a rotten egg. And also with lead-2 triazonitrate 5. Now, the test for hydrogen sulfide using lead-2 triazonitrate 5 is also the same thing as what we discussed under the reaction of hydrogen sulfide as a precipitating agent using lead 2 carbonitrate 5. Now, when the gas is passed into a solution of lead nitrate, a black deposit of lead 2 sulphide is formed. Now, I've said this before. Now, uses of hydrogen sulphide. Hydrogen sulphide is used in the analysis of ores and also of ores and metals. And that means we can use it to separate. I told you that sulphide gives distinct color. Like some sulphide have some colors, while others have some other colors like that. So we use hydrogen sulphide to separate which sulphide can behave like this. Because okay, let's say we have some sulphide that are black, some are white, and some are yellow. When we get to sulphide, we'll discuss about that. Now, also hydrogen sulphide is used to prepare sulphides of metals. Now that's where we're going to. Okay, I think I have some practice questions for you guys. Yeah, apart from lead nitrate, mention one reagent you can use in the test for hydrogen sulfide in the lab, and is hydrogen sulfide a strong acid? Now, you can contact us at www.scholarsuniversalschools.com or call 0033942989. You can also message the number. Now, thanks for watching this edition of Scholars Universal Secondary School online chemistry class. And you can like and subscribe to our on our YouTube channel at Scholars Universal Secondary School. Thank you.